During the discussion of reference frame, we have seen that we can classify the motion of a particle into three different categories. The first one is one-dimensional motion or rectilinear motion. The second one is two-dimensional motion or motion in plane, and the third one is three-dimensional motion or motion in space. We have also seen that how to define these three kinds of motion. Now in this video, we will start our study with rectilinear motion, and after studying rectilinear motion, we will add one extra dimension at each time, and we will find the motion of the body or a particle in a plane or three-dimensional space. So here we will define rectilinear motion and we will express it by mathematical equation with the help of certain motion parameters. We will learn about that motion parameters in the consecutive videos. So here we will start with the definition of rectilinear motion. It is a kind of motion in which the particle travels along a straight line. So whenever a particle is moving along a straight line, the motion of the particle will be a rectilinear motion. Now this kind of definition or this kind of explanation sometimes create a confusions also. Like if this is our reference frame, say OX and OY are the two axes of reference frame OXY, and the particle is moving like in this path, say along the path AB, either in A to B or from B to A, that is from forward or backward direction, that is from rightward or leftward direction, or then it is called to be a rectilinear motion. Also the particle can move along upward or downward direction, say along the path CD, and this kind of motion is also a rectilinear motion. But say the particle is moving along the path KL. Now it can be confused as a two-dimensional motion, because in this case we can find that the particle is changing its x and y coordinates. So it should be a two-dimensional motion. But here if we change the perspective from which we are looking, because there is no hard and fast rule that we have to consider only the reference frame OXY. If OX dash, say OX dash and OY dash is our reference frame from which we are looking the motion of the particle along the line KL, then obviously the motion of the particle along the line KL will be a rectilinear motion, because the particle is changing its direction only along the dimension OX. So it is a rectilinear motion. But suppose the particle is moving along a semicircular path like this. So whatever be the reference frame you are choosing, when the particle is moving along a semicircular path like this kind of path, the motion of the particle will be a two-dimensional motion, because in this case the particle is changing both its x and y coordinate and whatever the reference frame you are choosing. So this kind of motion is not a rectilinear motion. It is an example of two-dimensional motion or motion in plane actually. Now before defining rectilinear motion with the help of mathematical equation, we need to study certain motion parameters, and one of such parameters is distance covered, or it is sometimes known as path length. Now for a particle in motion, it is defined to be the distance covered by the particle in a particular interval of time. Now we can better understand with it with an example, like when the particle, say at time t is equal to 0, the particle is at point O, and after time t it reaches a point A covering a distance of x1, and say at time after time t2, say this time is t1, so after time t2 it reaches at point B covering a distance of x2, and say after time t3 it again covers a distance of BO and reaches again at the origin. So at t3 and t0 time the particle is at origin, and suppose after time t4 the particle covers a distance of x4 and reaches a point C. Now if we want to find distance covered by the particle at different instant or different interval of time, say for interval of time t1, distance covered by the particle is OA, and that is x1. But at time t1 plus t2, distance covered by the particle is OA plus AB, that is x1 plus x2. And at time t1 plus t2 plus t3, but at time t1 plus t2 plus t3, distance covered by the particle is OA plus AB plus BO, that is x1 plus x2 plus x3. And at time t1 plus t2 plus t3 plus t4, distance covered by the particle is x1 plus x2 plus x3 plus x4. So this is how we can calculate the distance covered by a particle when it is in motion. But during the discussion of motion, sometimes we need to know in which direction the particle is moving, or we want to know what is the ultimate position of the particle when it completes its motion with respect to the origin. So then we have to define a parameter with which direction property is associated, like displacement. So displacement for a particle can be defined as it is the distance covered by a particle at a given interval of time and at a given direction. So from the definition of displacement, now say we represent distance covered or path length by small d and displacement of the particle by x. From the definition of displacement, we can find that it has magnitude part, that is distance covered, so it has magnitude, and direction property. So it has, displacement is a physical quantity which associated both with magnitude and direction. So it is known to be a vector quantity, and if we mathematically want to find it, then we can define displacement x, which is a vector quantity. That is why we always represent it with an arrow over his head. So x is equal to final or ultimate position of the object minus initial position of the object. So if we analyze the motion of the particle like in the previous case, then we can find that if we want to know the displacement of the particle at different interval of time, say like on the previous case when the particle is moving along the path OA, AB, BO and OC, then we can find that displacement of the particle at time interval t1. It is obviously a vector quantity, and we find that displacement of the particle at time t1 is OA, because O is the initial position of the object and A is the final position of the object. So displacement of the object is OA, which is denoted by x1. and at time t1 plus t2 the particle moves from O to A and A to B. Therefore, initial location of the object is O and the final position of the object is V. So, the displacement of the object is OB, which can be represented by OA minus AB. Now, obviously, AB is taken as minus because the rightward motion of the particle is considered to be a positive one, then the leftward motion of the particle should have to considered to be a negative one. So it is x1 minus vector x2. Similarly, displacement of the particle at time t1 plus t2 plus t3 is equal to initial position of the object is O and final position of the object at time t3 is again O. So initial and final position of the object is same. That is why in this case we will find displacement of the object is 0. So we can find it to be like OA displacement of the object at time t1 minus AB displacement of the object in the time t2 on the reverse direction and BO displacement of the object at time t3. Now in this case we can find that OA minus AB plus BO. Now from the geometry we can find that AB plus BO is equal to OA. So OA minus OA and that is equal to 0. So this is why when the initial and the final position of the object is same, displacement you will find the displacement is equal to 0. But suppose we want to find the displacement of the object at time t1 plus t2 plus t3 plus t4. Then we can find that the displacement of the object to be OA minus AB minus BO minus CO. So obviously this part will be 0. So ultimately displacement of the object, sorry, it should be OC because the particle is moving from O to C. So ultimately displacement of the object will be OC. The particle is moving from O to C. So it is equal to minus x4. Now you can find that in ultimate displacement, when you got the ultimate displacement of the particle, you will find that this has two parts. One is sign, it is negative, and it indicates that the particle is situated leftward to the origin because the rightward to the origin movement is taken to be a positive. And x4 is the magnitude part which represents the amount, the distance from origin, the distance of the particle from the origin actually. So this is how we define displacement. So now to better understand it, suppose the particle is moving in a path like this. So particle is going from A to B and this is the path. ASB is the path along which the particle is moving. Now A is the initial location of the particle and B is the final location of the particle. So from the definition of the displacement, we can find that final minus initial position is the displacement of the particle, and that can be represented by the line AB. So displacement can be told as the shortest distance between the initial and final point. So we can write displacement to be shortest distance between final and initial point of an particle in motion, unless the final and initial point is not same, because when they are same there is no displacement or distance covered by the particle. So actually displacement vector define the effect of the motion but not the motion itself, but because the particle is actually moving along the path ASB, not along the path AB, so it is the overall effect of the motion of the particle. But there can be a situation when the particle is moving along the line AB. So if we take it to be case 1, when the particle is moving along path AB. So this is the shortest path. So it is a straight line because the shortest distance between any two points in plane is a straight line. So AB is a straight line. So in this case, we can say that distance covered by the particle, distance covered is equal to displacement of the particle. So it is a case where we have found that distance covered is equal to displacement. For any other path, the particle is like the particle is moving along ASB, or you can take any other path. Suppose the particle is traveling along the path, this path, or the particle is traveling along this path. So for AK, AM, so if the particle is moving along the path ASB or AMB or AKB for any other path other than AB path, the distance covered by the particle is always greater than displacement. So we can write a situation where distance covered is greater than x. But case 2, if we consider case 2, then we can say that when the particle is at rest. So when the particle is at rest, there is no distance covered by the particle. So there is no displacement also. So distance covered by the particle is equal to 0 and it is equal to displacement of the particle. So distance covered by the particle can be 0. Displacement of the particle can also be 0. But we can say that distance covered by the particle cannot be negative because either the particle is in rest or it is traveling or it is covering certain path due to its motion. So distance covered by a particle cannot be 0, but displacement of the particle can be 0. From the above example, we can find that when the particle is moving rightward direction, then the motion of the particle is considered to be a positive one. So obviously displacement of the particle can be a positive quantity. Again, when the particle is moving along the path, say AB, that is the particle is moving on the leftward direction, then displacement can be a negative quantity. So what we found that displacement x can be negative, can be 0, can be positive, whereas distance covered is always 0 or positive. So mathematically we can write it like this: distance covered is always greater than equal to 0. And we can also say that distance covered is always greater than equal to 0, and we can also say that this distance covered is always greater than equal to displacement, because there are certain situations where we have found distance covered by the object is equal to displacement. For any other situation, distance covered by the object is always greater than the displacement. However, both of this displacement and distance covered has the same unit because both of its magnitude path represents nothing but the path traveled by the object. So that is why we can say displacement and distance covered has same unit or dimension. And we know that in SI system the unit of length is meter and dimension of it should be m0 L1 T0.